So we're on the second video. We're going to start with number 3, which is a prism with bases that are trapezoids. So a trapezoidal prism is what this is called. Once again, we're going to find the parts that we're going to need to work with the other formulas. So the perimeter of my base is going to be 4 plus 5 plus 8 plus 3, right? Because that's all the sides of my base. So let me outline that. Okay, so 4 plus 5 plus 8 plus 3. So the perimeter of my base is 20 centimeters. And then the area of my base, remember I have to use that formula for trapezoids, and you have to make sure you identify your two sides of the trapezoid that are parallel, which is the 4 and the 8. So 4 plus 8 divided by 2 times the height. This is the height because it's showing the right angle between that and the other side there. So that's going to be times 3 as our height. So my area is 18 centimeters squared. And then we're on to our lateral surface area. So that's P times H, perimeter times the height of the prism. And the height of our prism is 6 because that is the length between the two trapezoids that are our bases on this prism. So perimeter 20 times the height of 6 gives me a lateral area of 120 centimeters squared. Part B is my total surface area, so the lateral area plus my two bases, so 2 times the area of the base. So we've got 120 plus 2 times 18 because that was the area of my base, and we end up with a total surface area of 156 centimeters squared. And then volume, right, is going to be the area of the base times the height. So 18 times our height of 6, and that's 108 centimeters cubed. Now, you have to be careful not to get confused about the height of the trapezoid, right? Just that base. Just look at the height of the trapezoid, which was the 3. Boy, you can't hardly see that circle. The 3 centimeters. And then the height of the trapezoid, which was the 6 centimeters, or the height of the prism. So sorry. So you've got the height of the trapezoid, 3, and we've got the height of the prism, which is 6. So just be careful on that whenever you're working on the ones that have that in the formula. Okay. All right, so to close out and get back in, that's what happens when I have a blank page come up. It's the same thing that we do in the classroom, actually. Okay, so this is a hexagonal prism because it tells us that the base is a regular hexagon. And so it's pretty clear on this, and it's also nice that we don't have to worry about the height of the hexagon, so you don't have any confusion there. Okay, so let's find the perimeter, which is just going to be 6 times 1/2 because the length of the side is 1/2. So 6 times 1/2, and that means my perimeter is just 3 inches. And then the area of the base, you're going to use that formula for area of a hexagon, 2.598 times a side squared. So my side length is 1/2. I'm just going to put in 0.5. And so area of our base is going to be 0.6495 inches. Okay, And then we can go ahead and find all the different parts here. So we're going to find A, the lateral surface area. All right, so P times H, perimeter times the height of the prism. And so perimeter is 3, height of my prism is 3.5. So the lateral area, remember that's the part that does not include the bases, is going to be 10.5 inches squared. So the next thing that we are going to find is the total surface area. I had a knock on my door and had to pause for a moment and answer. And anyway, so total surface area is the lateral area plus 2 times the area of the base. And we know our lateral area is 10.5. Plus 2 times the area of my base, which was 0.6495. All right, so when we multiply that out and simplify, it's going to round. Actually, this is rounded possibly too, I'm not sure, but 11.8 inches. Let me scoot that over a little bit. Inches squared. And then last we find volume, part C. I'm hoping that I'm giving you a process to help you with this. You're not going to have to find all 3 of these on this many in the future, but I just wanted to do every single type that we work with other than a cube. I didn't do a cube on here, but I wanted to give you good examples so that any of them you face, you have something to refer to. Okay, so area of my base, 0.6495 times the height of my prism, which is 3.5. So my volume is 2.27, a bunch of numbers. We're going to round that to 2.3. Once again, I want to remind you, just be careful with your rounding. Okay, so that is the basics on our prisms, and now we're going to go into some of the word problems. All right, so here's the first one. This is a welding problem, and I chose this because I have a lot of welding students, and so I thought that this would be a good one for that. The parts bin shown in the figure is made of 16 gauge sheet metal. Calculate the volume in cubic feet and the total length of weld needed in feet. Okay, so let's just talk about volume first. So to find our volume, we need the area of the base times the height. By the way, this is an open container, so it's open at the top. So the volume is just going to be the area of our base, which is 1 times 2.5, times our height, which is 6 inches. So we want to make that 0.5 feet, right? 6 divided by 12, and we can convert that to feet. So times 0.5. So I kind of just put that all together on this instead of finding the area separately, and it's because it's a rectangle, so I feel like that's kind of an easier shape to work with anyway. So we have a volume of 1.25 cubic feet, so feet cubed. Now let's talk about the length of the weld. So I'm going to try to draw all the places where they're not that, all the places where we're going to weld, right? We've got all along the edges to put this box together, right? So we have 1 foot plus 1 foot plus 2.5 foot plus 2.5 foot, and we have all the corners. So that's going to be 4 of those. Oops, I missed there. Oh, get on there. Okay. And so to find the length of the weld, we simply add up the 2 times the 1 foot plus 2 times 2.5 feet plus 4 times the 0.5, that's our corners, right? The corners are going to, there's 4 of those. And so when I add that all together, I'm going to have 2 plus 5 plus 2. So the length of the weld is 9 feet. All right. So that's it for that problem. And there's a lot of different ones where you have to do some converting, as part of the problem. So this next one is a painting problem. So we're painting a house or painting a building that's 26 feet high. It says how many gallons of paint are needed for the outside walls of a building 26 feet high by 42 feet by 28 feet. So let's think about that. Length times width, right? Length, width, and height. Okay. If there are 480 square feet of windows, so we've got to subtract out the windows, and 1 gallon covers 400 square feet. Assume that you cannot buy a fraction of a gallon. Okay, so we're going to find the lateral surface area of this place, because we're not painting the top, the roof. We're not painting the roof. We're not painting the bottom. That's the foundation because it's a building. So we're just painting the sides of the building minus the windows. Okay, so the perimeter, let's find this over here, is going to be 2 times the length plus 2 times the width, because it's a rectangular shape, right? It's a rectangular base. And so that's going to be 140 feet for our perimeter. So then to find our lateral area, our lateral surface area, we take 140 times our height, which is 26 feet. And we find that it's 3,640. But then we have to also subtract our windows, right? That's the area of our windows. So our lateral surface area is 3,160 square feet. And then we're going to see how much paint it's going to take. So we put 3,160 square feet over 1 and 1 gallon of paint. Now I'm showing you this because sometimes students are having a hard time figuring out what their units are at the end, and I want to show you that we cancel out the feet squared. We end up dividing by the 400, which I think a lot of times students know that, but we want to get the right units, and in this case that would be gallons. So it comes out to 7.9, which we're going to round to 8 gallons of paint because we have to buy full gallons. All right, so that's it for that problem, and we're up to about over 13 minutes, so I will do another video. I'm not sure if I have to do 1 or 2, but at least 1 more. All right, bye everyone.